Hello, everyone, and welcome back to another lecture for Math 104. In the previous lecture, we were discussing inequalities, and we were talking about how to solve inequalities and what to do. We talked about your basic linear inequalities. We also talked about compound inequalities, and then finding the interval of values. So, finding the new endpoints, and that's where we, played that little game. You picked a number that was in your original, your original interval. And then at the end, you could see if your number after the operations, were done to it, still worked inside your new interval, and it should. It absolutely should, because whatever operations you did to your inside pieces would apply to your outside pieces. So that was all in the last lecture. Now today in this lecture, what we're going to do is we're going to look at more inequalities, but we're going to be discussing instead of just linear inequalities, which your highest power is 1. Now we're going to be looking at what happens if your highest power is 2, for example. So if we have a quadratic inside of our inequality. And also, we're going to see what happens if we have rational expressions inside of inequalities. So, if we have a polynomial over a polynomial and it's part of an inequality, we have to see how we solve that. Okay, so once again, the best way to do this is to just jump into an example, and then we'll go through the process together and see how we're supposed to do this together. Okay, so the one thing that we have to do when we look at something like this, and the example that we're going to start with is x squared plus 2 is less than 3x plus 6. So looking at this, the process that you use to solving a quadratic while inside or while a part of an inequality is actually very similar to what you would do if it were part of an equation. So if you had an equal sign instead. And what do we know about quadratics? Well, for 99% of the time, unless we're trying to do something like completing the square, what we have to do is we have to get it into standard form, right? And standard form is where there's a 0 on one of the sides. So you're going to follow that same exact process. So what does that mean? Well, here I see that I have an x squared on my left side. I don't want to move my x squared over and make that negative. So I'm going to keep that positive, and I'm going to move over the 3x and the 6. And that way, what I can do is I'm going to move over, I'm going to make it 0 on one of the sides. So that's my game plan here. Okay. So having said that, we're going to go ahead and do that. And we end up with x squared minus 3x. And then, because again, I'm subtracting 3x from both sides, and I'm subtracting 6 from both sides as well. So subtracting 6, we get 2 minus 6, which is negative 4. Now this is less than 0. So we have x squared minus 3x minus 4 less than 0. And again, this should look really similar. Just the only difference right now is that instead of a less sign, you're used to it being an equal sign. Okay, well, go ahead and factor this. Let's see how we factor this. So to factor, we look at factors of negative 4, right? So looking at factors of negative 4, they have to multiply to give us a negative 4. So one of them has to be positive, one has to be negative, and add together to give us a negative 3, right? So the ones that come to mind are negative 4 and positive 1, right? When they multiply, they give you a negative 4. When they add, they give you a negative 3. So great. So we can say x minus 4 and then x plus 1 is less than 0. And now, if this were part of an equation, what you would do, and what we're going to do regardless, is we're going to take both of our factors here, now that our quadratic has been factored, and we're going to write off, okay, well, x minus 4 is equal to 0, and then we'll say x is equal to 4, right? And x plus 1 is equal to 0, x is equal to negative 1, right? Okay, so this is your normal stuff. But we're dealing with a less than sign, right? And we're saying less than 0. Essentially, what we're trying to find out is we're looking for all of the possible numbers that are going to make this, the left side, less than 0. And what does it mean to be less than 0? Well, if it's less than 0, that means that it's negative, right? So we're looking for all the possibilities that we can put into x that's going to make this inequality true. Essentially, what we're saying is we're looking for all the different numbers that would make the left side negative, okay? So to do that, what we have to do is we have to take our factors that we just solved for. So in this case, x is equal to 4, x is equal to negative 1, and we have to go ahead and plot them onto a number line. So we draw a number line as such, and we just put them on. So negative 1 here, 4 here, right? And when we do this, again, are we including our factors? Well, no, right? We're not including it because it's a less than sign, right? It's not a less than or equal to, so we don't want to actually include those numbers. So we're going to put open circles around them. And now when you see this, you realize that there's actually 3 sections that we broke our number line into, right? There's everything, and I'm just going to shade this in red real quick. There's everything that's to the left of -1. There's everything between -1 and 4. And then there's everything that's after 4, right? So what we have to do is we have to pick numbers from each of those places. So we have to pick a number from here, we have to pick a number from here, and we have to pick a number from here. And what we're doing is we're going to test those areas. The reason that we can just pick one of those numbers, because all of the numbers that are in, let's talk about the green area, which is the area on the far right, all of the numbers after 4, all of these should behave the same. Essentially what we're saying is that at -1 and at 4, we're going to get a 0 on the left side, right? And the reason that we're not including these numbers is because 0 is not less than 0, right? So go ahead. Let's say, for example, we did want to plug in 4, right? 4 for x. Well, if we plugged in 4 for x, just hypothetically, we would get 4 minus 4 here, and 4 plus 1, which I don't really even care about what that's going to be, which it's 5, but either way, because we know that 4 minus 4 is 0, and 0 times anything is going to be 0, and then we would get 0 is less than 0, right? And we know that that's not true, and that's why we're not including 4 and -1. As far as why we can just pick a number from those 3 intervals, well, if we pick, let's say, 5, 5 is going to behave the same way 6 does, and 6 is going to behave the same way 7 does. What I mean by that is that if 5 makes this underlined area here negative, then 6 is also going to make it negative. 7 will also make it negative, so on and so forth. The parts where it flips, the parts where we're not sure about is, well, we don't know what about, the area between -1 and 4. And we also don't know about the area before -1. So we have to pick test points so that way we can test all of them. So what we're going to do is we're just going to pick any old test points that work for us, and we'll see what happens. So for the green area, I just mentioned 5. So I'm going to go ahead and say, all right, I'm going to just make it 5, right? Why not? Okay, so then the next thing that I have to do is for the blue area. Okay, the blue area, I can pick any number between -1 and 4. I'm going to pick 0 because 0 lies between -1 and 4. And before -1, make it easier on yourself. Make it, as low as a value as possible. So in this case, I'm going to say -2, or as least of a value as possible. Sorry, my mistake. So I'm going to say -2 here. You could say -3, -4, whatever helps you conceptualize this. Whatever is easier for you, pick the easiest number as long as it lies within that interval. So now what we do is we test them. And how do we test them? Well, we're going to plug in all of these test points, the 3 test points that we just got, and we're going to plug them in right in here into our factored inequality. So we're plugging in into x minus 4 and x plus 1 is less than 0. So we're going to say in red, wherever there was an x, we're going to plug in our test point. So -2 plus 4, sorry, minus 4. Oops, that would have been unfortunate. -2 minus 4, and then -2 plus 1 is less than 0. Okay, well, -2 minus 4 is going to give us a -6, but I don't actually care about what the number comes out to be. The fact that it comes out to be a -6 doesn't necessarily matter to me. I just care whether it's negative or positive, and we'll see why in just a second. So I'm just going to write a negative sign here. Whether it's -6, -7, doesn't matter to me. So I'm going to write a negative there. And now -2 plus 1 is also going to come out to be negative. So I get a negative times a negative, and we know that a negative times a negative is going to be a positive number. And is a positive number less than 0? No, right? So this is out. This one is not going to be part of our solution. The reason that I don't care whether it's -6 or -7 or whatever is because when I multiply it against my other sign, which in this case is another negative number, -6 and -7 times a negative number is going to give me a positive number back. We're only looking to see whether our number is less than 0 or not, right? So all I'm checking to see is the sign of the number. If you want to do all of the math out, if you did write, okay, well, -2 minus 4, -2 plus 1 is less than 0. If you wanted to write it out and it helps you understand it better and you say, okay, I get -6 here, great. I get -1 here, great. And I end up with a -6 times -1, which is a +6. Sure, you could totally do that. But the key thing here is that 6 is really a +6, which means that we're just basically saying, is a positive sign, is any positive number less than 0? And the answer is going to be no, right? So then, of course, you would say, great, this doesn't work out. This is not going to be part of your solutions. Okay, so now we know for fact that this area, this entire area, would give you a positive result. And you can go ahead and, if you don't believe me, feel free to pick another number from this red area, or the area to the left of -1. You can pick -3, -4, so on and so forth. But as long as one of your numbers, in this case, we pick -2, gives you a positive result, all of the other numbers in that interval are also going to give you a positive result. So now we have to go and test the other two intervals. So the other interval that we're going to do now is the blue interval, or the middle interval, which is 0. So we're going to test 0, and we're going to say, okay, we have 0 minus 4, and we have 0 plus 1 is less than 0, and we say, okay, well, we get 0 minus 4 is a negative number, 0 plus 1 is a positive number, so we get a negative times a positive is less than 0, right? And negative times a positive is a negative, and we know that a negative is in fact less than 0, right? That's by definition, any negative number is less than 0. So hooray, this one works, which means that this interval is going to be part of our solution. When we write out our total solution set with, when we write it in interval notation, this interval will be part of our solution. So great, we know that the interval between -1 and 4 is correct. This is going to work for us. So now we just have one last interval to test, and that's going to be the green area, or the area to the right of 4. And in this case, we're choosing 5 to be our test point. So choosing 5 to be our test point, we are going to write, great, okay, plugging in wherever there is an x, we have a 5 minus 4, and then 5 plus 1 is less than 0. Okay, 5 minus 4 leads me to a positive value. 5 plus 1 is another positive value. We know a positive times a positive is really just a positive, and is a positive less than 0? Well, no, we just saw that in the red area, right? In the first one that we did. So this one doesn't work out. So great. The only solution area that we care about is the blue one, the middle piece. So now what we can properly say is that the answer to our, the answer here that we're looking for is simply between -1 and 4, not including those numbers. So because again, we got a negative here and positive here. And the reason that we care about this interval is because, once again, we're looking for all of the numbers that were less than 0, all of the numbers that would make the left side less than 0. Hence, we only care about the middle interval from -1 to 4. So we write our final solution set being -1 to 4, and obviously we use parentheses because, once again, we are not including those values, right? So this is your final answer. And now you should, if you want, double check that this works. Go ahead and verify, because we verified with 0, right? 0 was our test point. You can try other numbers. If you wanted, we can try 1, right? If we tried 1, essentially, 1 should still work. If x is equal to 1, that should still work. Why should it still work? Well, it's inside of our middle interval. 1 is between -1 to 4, right? So if we went back to all the way to our original answer, right? And if we wanted to do a check, we can plug in 1. And if we plugged in 1, and I'm just going to quickly do this, I'll put it in green. If we plugged in 1, we would have 1 squared plus 2 is less than 3 times 1 plus 6. 1 squared is 1, plus 2 gives me 3. 3 is less than 3 times 1, which is 3, plus 6, which is 9. So we get 3 is less than 9. Hooray! So it works, right? We now see that all of the numbers in that interval would work. Okay? So the process is relatively straightforward. Just to recap, what we're doing is, when we have a quadratic, we're going to do the same things that we would with if it were an equation. We're going to get one of the sides to be 0. Specifically, doesn't really matter, as long as you just make sure that you're following the normal rules of inequalities, which is that if you multiply or divide by a negative number, you have to flip the sign. Okay, but otherwise, it doesn't really matter which side is going to be 0. Just make one of the sides equal to 0, and then factor. And once you have it factored, you're going to solve for your 2 factors of your quadratic. In this case, what did we get? We had 4 and we had -1. And those on your number line are going to break up the number line into different sections, into different intervals. You have to choose a test point for each interval and see whether those test points make your inequality true or false. And as we saw, the outside intervals, the intervals from negative infinity to -1 was false, and the interval from 4 to positive infinity was also false. The only interval that made our inequality true was the middle interval, which was from -1 to 4. Hence, that was your final solution. So your final solution is from -1 to 4. Okay, so I'm going to go ahead and clear this off. I want to give you guys the opportunity to go ahead and try your first classwork assignment. Your classwork assignment is x squared, wow, that came out terrible, x squared, that's a little better, plus 4x is greater than or equal to 5x plus 6. Okay, so what I want you guys to do, and I think I'll say it during when I type it up for the classwork assignment, go ahead, solve this. Make sure that you're plotting it on the number line, make sure you're solving it with test points, and that your final solution is in interval notation. Okay, so go ahead and give this a shot. Okay, so hopefully it wasn't too bad. Again, first step is going to be the same first step that we do if this were a regular equation, in that we're going to move all the things over to make this in standard form, right? Standard form means there's a 0 on one of the sides. So x squared we're going to leave untouched. I'm going to move my 5x over. So I had 4x minus 5x, which leaves me with 1 negative x. Okay, and now we had no constant on the left. We're subtracting a 6, so 0 minus 6 leaves me with a -6 here, and this is going to be greater than or equal to 0. Okay, we go ahead and factor this now. We're looking at factors of -6 such that they multiply to give us a -6. So one positive, one negative factor. And then when they add, they give us a -1, right? Again, we're looking, they need to add to give us that middle piece there. So this should work out, right? -3 and 2. We can factor such that, okay, great. When they multiply, they give us a -6. When we add, they give us a -1. So we get x minus 3 and x plus 2 is greater than or equal to 0. Okay, we do the same thing, right? We break this up. We know that our factor pair is going to be x is equal to 3 and x is equal to -2. If you don't see how I got that, set it equal to 0 and then just do your either add or subtract, right? And now what we're going to do is we're going to take these 2 points that we just solved for, and we're going to plot them on the number line. So we put a number line down here. We say, great, -2, 3, and now here's the question for you. Do we put an open circle or a closed circle on each of our factor pairs? And the answer is we put a closed circle. Why do we put a closed circle? Well, again, keep in mind that 3 and -2 are the only numbers that are going to make your left side of the inequality be 0, right? And we would have then 0 is greater than or equal to 0, and that is a true statement, right? 0 is greater than or equal to 0. So we would put a closed circle or a filled in circle, however you want to put it. Okay, so now once again, we have 3 different intervals that we have to pick from, right? We have to test this, the outside one, the inside one, and the outside one on the right side. So we have to choose test points that are going to work for all of these, right? So a test point that's between -2 and 3, for me, the easiest one that comes to mind, 0, right? Make life easier on yourself. Why do extra work if you don't have to? So put a 0 because, again, you could choose 2, you could choose -1, you could choose a fraction for all I care. It doesn't matter as long as you do your math right. But I'm choosing 0 because it's going to make my life easier. Okay, so now once again, I need a number that's to the right of 3. So I'm going to choose 4. And a number that's to the left of -2, I'm going to choose -3 here. So what we're doing is now we're going to go ahead and test all 3 of our test points, and we're going to see what makes the inequality true or not. Okay, so let's go ahead and test x is equal to -3, right? So we're going to test this one first. Okay, so what was our inequality when it was factored? Well, it was x minus 3 and x plus 2. So I'm going to have -3 minus 3 and -3 plus 2 is greater than or equal to 0, right? Minus 3 plus 2? Yeah, minus 3 plus 2. Great. Okay, so now we go ahead and we say negative 3 minus 3. Well, this gives me a negative number. Negative 3 plus 2, that should also give me a negative number. So I get two negatives, and two negatives multiplied together gives me a positive. So we get a positive number here, and a positive is in fact greater than or equal to 0, right? So great. This interval works. We have now shown that the leftmost interval from negative infinity to negative 2 will in fact make our inequality true. So all of these numbers here are going to be good. Okay. All right. Solid. So moving forward, and we'll go ahead and put a plus sign just so we understand, and it's good to keep track, just so we understand that that interval makes our inequality positive. Okay. So now we have to check x is equal to 0 because that was our middle test point. So x is equal to 0, 0 minus 3, 0 plus 2 greater than or equal to 0. Well, 0 minus 3, really easy, right? We know that's going to be a negative number. 0 plus 2, that's going to be a positive number. And a negative times a positive is going to be a negative number. And is a negative number greater than or equal to 0? No, right? So this one does not work, which means that our middle piece, our middle interval from negative 2 to 3 is not going to be part of our solution set. So we put a negative there because that's what it, that's what it's representing, right? When we plugged in 0, we got a negative number back. So we know that from negative 2 to 3, that interval will not work. Okay, we have one last test to do. So we're going to do x is equal to 4. So x is equal to 4. Okay, and now we plug in 4 minus 3 and 4 plus 2 is greater than or equal to 0. Well, 4 minus 3 gives us a positive number. 4 plus 2, that's also very clearly a positive number. Positive times a positive gives us a positive number back. And we know that a positive number, once again, is in fact greater than or equal to 0. So hooray, that one does work. And so we know that we can shade that entire area in, right? So we can do all that because this one does work. And now all we have to do is just put our intervals together that worked, and that's going to be our final solution, right? So the interval that worked is from negative infinity to all the way up until negative 2, right? And now, once again, do we put a bracket or do we put a parentheses? Well, we wanted to include our factor pair, right? That's why we put the closed circles. So we put a bracket here because we're including negative 2. Negative 2 is still going to make that inequality true. Okay? And now we had another interval, and the other interval that worked was from 3. So starting from 3, including 3, all the way to positive infinity, right? All the numbers after 3 are also going to work. And we showed that by choosing 4. So we say, okay, we're going to include 3. And it goes all the way to positive infinity. And once again, doesn't matter if it's negative infinity or positive infinity, you have to put a parentheses there because you can never be at infinity. And the last thing that you have to do is just put them together, right? It's this interval and another interval. So we union them together, and that's your final solution. Okay, and that's it. For the record, I also want to just touch on a slight notation thing. I know that this is just a Math 104 class. I'm not sure if you'll see it in a pre-calc book. So if you go on and take pre-calc, I'm not sure if you'll see it there. But if you go on and take calculus, you'll definitely see this. You'll see this little symbol, so x, because that's our variable, and you'll see this. This means an element of. It looks kind of like a weird E. So x is an element of, and then this combined interval. Essentially, that's just saying that your variable, doesn't matter what it is going to be some number in this interval. And technically, this is the correct way or the most correct way to write your final solution. But for the purpose of this class, you don't have to write that. Just give me this piece. So just give me this and I'll be happy. Okay, I'm only showing you guys that because if you go on to take other more advanced courses, I want to prepare you with kind of the other notation that you'll see, and that's going to be in there. Okay, but once again, negative infinity to negative 2, including 2, and then from 3, including 3, to positive infinity, and this is going to make our inequality true. So this is our final solution. Once more, going over the steps, we moved everything over to one side. We got it in standard form. We factored it. We found our factor pair to be 3 and -2. So we put 3 and -2 on our number line. We then realized, okay, we have 3 different intervals that we have to pick from. So we chose test points for each interval. So -3, 0, and 4 were my test points. You didn't have to pick those. Those were just the ones that I picked because I made my life easy. And then I just tested them to see where things would be true, right? We saw that -3, plugging that number in would result in a positive number on the left side, and a positive number is going to be greater than or equal to 0. We saw that by plugging in 0, we got a negative number, so that was false. That wouldn't work. But plugging in 4, we also got a positive number back again. So we now saw that 2 different intervals made our solution true. Hence, we had 2 intervals that we had to combine together, and this was our final solution. It's really not too bad once you really get the hang of it. It's really just a lot of work. It's a lot of tedious work. It's not like, you know, a lot of like difficult things put together. It's really just a lot of the stuff that we already know how to do, right? We already know how to factor. We already know how to solve for our factor pairs, right? We solve for 3 and -2. We definitely know how to plug numbers in. We've been doing that for our checks, right? So plugging numbers in isn't too bad. It's just the fact that we have to do it multiple times. So hopefully it's not, you know, too far-fetched from what we've been learning so far. Okay? All right. So let's go ahead and move on now. Next up, we are going to talk about rational inequalities. What is a rational inequality? Well, whenever you see the word rational, you can always assume a fraction, right? Rational means, you know, like rational number, A over B, that type of thing. So a rational inequality is where you have a rational expression, but just part of an inequality. You still have to use test points to solve rational inequalities, okay? So let's look at an example here. We have 2x plus 5 all over x minus 1 is a less than or equal, sorry, that's like killing me. There we go. Less than or equal to 1. Okay, so how do we do this? Well, what we have to do is we have to obviously get to test points, but one of the things that we had to do to get to test points was we had to find out the parts where it would change from negative to positive, right? And what do I mean by that? Well, if you recall from the last example, one interval changed from, you know, that entire interval from negative infinity all the way until I believe it was -3 or -2, something like that in the last example. You know, it went all the way up until there, but at -2, it was 0, right? And then it switched over to positive values, and then, you know, switched back to negative, or whatever the case may be for whatever the last example was. But point is that you had an interval that was all one sign, and then it switched to another interval that was all another sign, right? And at some point, it has to switch, right? And there's a specific number that it switches at. And that's what we found was, well, that was our factors. That's where it switched at. Well, we have to do the same thing here. And what I mean by that is we have to move that 1 over, because what we want to do is we want a 0 on one of the sides. So that way we can test whether it's positive or negative, right? By definition, if it's less than 0, then it's going to be negative. If it's greater than 0, it's going to be positive. Right now, it's going to be really hard to do that because we have a 1 on one of the sides. So does less than 1 necessarily mean negative? Well, no, right? 1/2 is less than 1, but 1/2 is a positive number. So that's not really going to help us. So our first step here is we're going to move that 1 over. So we're going to say, okay, 2x plus 5 over x minus 1 minus 1, right? We move that 1 over, and now we have less than or equal to 0. Okay, this is looking a lot better already because now we can definitely start seeing comparison when we get to test points, whether or not we're doing, you know, whether it's less than 0 or greater than 0, whether it's negative or positive. Okay, well, we aren't entirely done because we don't really know what our starting points are at that are going to create those intervals. Recall again from the last 2 examples that we did, we knew what the intervals were going to be because our factors separated the intervals, right? Well, we aren't there yet because we don't have factors. This isn't factored. So what I have to do is I may have to make that -1 into a fraction, combine my fractions, and then I will have factors, right? Then I'll have factors on the top and factors on the bottom. So let's go ahead and do that. And how do we convert 1 to be a fraction? Well, we see that it's -1, right? We have subtraction. So we know that when we do convert 1 into a fraction, we're going to be subtracting 2 fractions, right? So what I want to do is I definitely want to make sure that the denominator of 1 is going to be the same denominator of my 2x plus 5 over x minus 1, right? That way, when I subtract fractions, I can actually do it, and I don't have to worry about changing denominators. So we keep our 2x plus 5, we keep our x minus 1, and now this is going to be x minus 1 over x minus 1, right? Negative 1, well, we'll just talk about 1. 1 is any number over itself, right? X minus 1 divided by x minus 1 is the same thing as 1. They would just cancel out, right? So all I did was I just changed the form. I changed the appearance of it, but I didn't change the value. And the reason I changed the appearance is, once again, so I have common denominators, so that now I can go ahead and subtract the fractions. And this is still less than or equal to 0. Okay, so subtracting fractions, well, we all know how to do this, right? We keep our denominator, and we just subtract the numerators, right? So it's 2x plus 5 minus, and now please don't get confused, right? When you subtract and you have multiple terms in your numerator, your negative applies to the whole thing, right? So your negative is going to apply to x, and your negative is going to apply to negative 1. So it's still less than or equal to 0. And now we get 2x plus 5 minus x, right? Negative applied to the positive x gives us a negative x. Negative applied to the negative 1 gives us a plus 1. And this is all over x minus 1 less than or equal to 0. Okay, we keep going. We get 2x minus x, which leaves us with 1x left. And we have a positive 5 plus 1, which is plus 6 over x minus 1. Okay, and now you say to yourself, okay, there's no more simplification we can do. We're essentially, you could argue that we're basically factored, right? Because there's no other pieces that we can, simplify. There's no other things that we have to expand, right? So now what we do is we take our denominator and our numerator and set them equal to 0, much like what we did when we were, when we got our factor pairs from the quadratic. So we say, okay, x plus 6 is equal to 0, x minus 1 is equal to 0, and we get x is equal to negative 6, x is equal to positive 1, right? Okay. Now, we go ahead and we do the same exact thing. We plot on the number line, negative 6, 1, and I don't really draw this to scale. This is totally fine as long as you just get them in order. I have to sneeze. I'm so sorry, guys. Give me 1 second. Okay, there we go. Did not want to sneeze in the recording. That would be very unfortunate. Okay, so we have negative 6 and we have 1, right? Now we just have to figure out what circles we're going to put here to make this true. Well, if we had a negative 6, well, we know that we would get a 0 in our numerator, right? Negative 6 plus 6 gives us a 0 in our numerator, and we would get a non-zero value in our denominator, right? Negative 6 minus 1 gives us a negative 7, so we would get 0 over negative 7, and 0 over negative 7 is the same thing as 0, right? And 0 is less than or equal to 0, right? So if we plugged in negative 6, we know that negative 6 is still going to make the inequality true. So we can definitely go ahead and put a closed circle here. That's going to be okay. But what about 1? Well, if we plug 1 in, we would get 1 plus 6 on top, which gives us 7. So we'd get 7 up here. And then 1 minus 1 is 0 in the denominator. And is 7 over 0 equal to 0? Well, no, right? 7 over 0 is undefined. This is, remember, we're going back to domain, right? We're talking about what breaks your inequality. And if we have a 1 for x, then our fraction breaks, which means that our inequality falls apart. 7 over 0 is undefined. We, say not available, no answer, whatever the case may be, right? So this is not allowed. Okay, well, if that's the case, if we can't have x is equal to 1, then we have to exclude it, guaranteed. Even though it's a less than or equal to 0, you have to realize that plugging in 1 will not make your left side 0. It makes your left side undefined, which makes the whole thing undefined. So that means that negative 6 is going to be filled in while 1 is not going to be included, okay? Okay, well, now we just go ahead and do our normal stuff that we just did before. We choose test points, right? So once again, I have this piece, I have this piece, and I have this piece. And as a heads up for you, if you guys haven't figured it out already, you're always going to have one more interval than you have solutions. So we had negative 6 and we had 1. So because we had 2 things that we pulled out from our fraction, we have 3 intervals. So you're always going to have one more interval than the numbers that you're plotting on your number line. Okay, so, and again, that's good to keep in mind, because if you plot 3, and you only have 3 intervals, you definitely mess something up. Whether you didn't plot enough points, or you plotted too many, or you just drew your number line incorrectly. It's just good to keep in mind that you're always going to have one more interval than the number of points you're putting on the number line. Okay, so we have this piece in the middle, and between -6 and 1, well, I have 0 again, right? So again, make my life easy. I'm going to put 0 as my test point. Over here, I'm going to choose 2, and over here, I'm going to choose -7 because it's the, it's the closest and least negative value. I really want to try to just make my life easy, right? So let's go ahead and test -7. So testing -7, right? What we're going to do is we're going to have, okay, we had x plus 6 over x minus 1, and we're just going to plug in, right? So while plugging in, we get -7 plus 6, we get -7 minus 1, and -7 plus 6 is going to give us a negative number on top. -7 minus 1 is another negative number, and a negative divided by a negative is a positive. And remember, we're looking for all of the numbers that are less than or equal to 0, right? Less than or equal to 0. Is a positive number less than or equal to 0? No, right? So this will not work. So -7 and the entire interval that's to the left of -6 is not going to make a negative number. So we put a positive up here and we say, great, we can't do anything else with that interval. Okay, now we look at from -6 to 1. Okay, so we're testing 0 now, right? So we're going to test 0. And what that means is we're going to have 0 plus 6 over 0 minus 1. Well, 0 plus 6 is a positive number. 0 minus 1 is a negative number. Positive divided by a negative is going to give us a negative. And is a negative less than or equal to 0? Absolutely. So, hooray, that works. Which means that this entire interval from -6 to 1 is going to work out. So this is totally okay for us. Okay? All right, moving down along, we have one last interval. We have to test 2. So testing 2, we get 2 plus 6 over 2 minus 1. And I think you guys can start seeing a rhythm here. 2 plus 6 is going to give us a positive number. 2 minus 1 is also a positive number, which is a positive number. And a positive is definitely not less than or equal to 0. So this one doesn't work, which means the only solution that works is our middle interval. So our middle interval from -6 to 1. And once again, just make sure you're writing it correctly. -6, including -6. So we write a bracket to 1, not including 1, because remember, at 1, our inequality breaks, right? The fraction breaks. So this is our only solution. This is the only interval that works, and this is it. Okay, so hopefully that's not too bad. Let's move on to a slightly more challenging problem for rational inequalities, and then we'll put you onto your last classwork, and that'll be it for today. Okay, so let's say we had x squared minus 3x minus 4 all over x minus 4, and this should be greater than 0 in theory. Okay, so we're looking for all of the numbers, all of the values of x that would make this greater than 0. Okay, well, to do this, we have a rational expression, right? And what did I tell you guys to do when we had a rational expression with an equation? Well, I told you guys factor as best as you can, and then when you factor, you should be able to cancel things out, right? This is the only exception, this is the biggest exception between a rational inequality and a rational equation, okay? When we factor, we're not going to cancel anything out. And I'll show you why in a second, but we're still going to factor, okay? So we have to factor the top, right? Because we have a quadratic on top. So we have x squared minus 3x minus 4. We know that we're going to look at factors of -4. So in doing that, we know that we're going to get x is x minus 4 and then x plus 1, right? Because -4 and +1, when they multiply together, they give you a -4. -4 plus a +1, right, is going to give you a -3. So this works out. So now we have x minus 4 times x plus 1 over x minus 4 greater than 0. Well, this is strange, right? We have an x minus 4 up top and x minus 4 on the bottom. And normally, if this were an equation, you would just say, oh, great, I can cancel these and I'd be done. The problem is, remember what our goal is. Our goal is we're trying to find the numbers that are going to split up our intervals, right? So if we do that, we would say, okay, x minus 4 is equal to 0, x plus 1 is equal to 0. And remember, I would normally say write out the top and also the bottom, set, the top and the bottom equal to 0. But because we have x minus 4 up top already, I don't actually need to do that a second time, right? So I can just say x is equal to 4 and x is equal to negative 1. Well, if I crossed out the x minus 4, then I would be crossing out this number, x is equal to 4, on my number line. When I go to plot my number line and I put, okay, negative 1 here, well, if I crossed out the x minus 4 factors, I would only be left with 2 intervals, right? I would just be left with this interval here and this interval here. What was to the left of negative 1 and what was to the right of negative 1. Well, we can't do that because we care about the, there we go. I was trying to get rid of that red line. What I'm trying to do is I'm trying to get all of the intervals that I care about that I need to test, right? So if I crossed out x minus 4 up top and bottom, then I'm essentially crossing out an entire interval, and we can't have that. So what I'm going to do is we're going to keep the x minus 4 on the top and the bottom. We're going to still plot negative 1, and we're still going to plot the 4 here. And now what you see, the difference is that we have 3 intervals, right? Plotting that 4 means that we're going to have an interval here and also an interval here. So we have 3 in total as opposed to just 2. Now the trick, once again, you have to just figure out if it's an open circle or a closed circle, right? Well, we know that for negative 1, it's definitely going to be, well, it should just be an open circle. And the reason is because if you put a negative 1 in, well, negative 1, we're going to get a negative 1 plus 1 right here, right? And that means that we're going to get a 0 times some other number. 0 times any number is 0, which means we get a 0 in the numerator. And is 0 greater than 0? No, absolutely not, right? So we know that this is going to be an open circle. Okay, and then for 4, once again, this one should be pretty easy to keep in mind as well, right? You look and you say, well, what happens if I plug in 4? Well, I get a 0 up top, and this breaks for 2 different reasons, right? If you were just talking about the numerator, you'd get a 0 up top and you'd say, okay, well, 0 is definitely not greater than 0, so hooray, we don't include it. Or the other reason, and the one that's more important, is that you would get a 0 in the denominator, right? You would get a 4 minus 4, and 0 in the denominator means that your fraction is undefined. So you automatically would have to put an open circle. Even if you got, a real number that wasn't 0 up in the numerator, you know that because your fraction breaks, it's an open circle. So now we have 3 test points that we need to test, right? Here, here, and here. So I am once again going to pick 0 because make my life easy. I'm going to pick 5 and I'll pick negative 2. Okay, so doing all of this, we're going to say, okay, we're going to test. And I'm going to put negative 2 here. So testing negative 2, we would have, and we're starting with x minus 4 times x plus 1 over x minus 4. And this is actually really neat because you have the same factor on top and bottom. You actually, without having to do too much math, if you can just do one of the factors up top or one of the factor on the bottom, you know what the sign on the top or bottom is going to be. So what do I mean by that? Well, let's say we plug in negative 2, right? So we have negative 2 minus 4, and then negative 2 plus 1, and then negative 2 minus 4 again. Well, if you know that negative 2 minus 4 is going to give you a negative number, you know you're going to get a negative on the top and a negative on the bottom. So you would get, without even having to think, you know you're going to get a negative and a negative here. And what I mean by that is, again, the sign here is going to be the exact sign that you get here because, again, it's the same factor, right? So we have a negative over a negative, and now we just need to see what is negative 2 plus 1. Well, that's another negative. So we get, I was going to say we get 3 negatives, and I wrote negative 3. Sorry about that. So we get 3 negatives, and how do negatives cancel? Well, they cancel in pairs, right? So if they cancel in pairs, we know that they cancel like that, and we're just left with 1 negative left. And what was our original inequality? What was the sign? We're hoping that it's greater than 0, right? So is a negative number greater than 0? Nope. A negative number has to be less than 0, right? So this would not work out. So we know that this entire interval from negative infinity to negative 1 does not work. We got a negative side here. Okay, now we have to test 0. So testing 0, we get 0 minus 4 times 0 plus 1. And this is over 0 minus 4. Once again, 0 minus 4 is a negative, so we know we're going to get a negative here. We know we're going to get a negative here. 0 plus 1 is a positive, and we know that negatives are going to cancel out, and we're just left with our positive number. So positive is greater than 0, and hooray, positive is in fact greater than 0, so that interval will work. So our middle interval, going way back, whoa, did I pass it? I feel like there it is. Our middle number, or our middle interval, is going to work, so that entire interval is going to be shaded in, right? We care about this whole interval. Okay, now we just have to check 5 and see if that works. So checking 5, well, we have 5 minus 4, 5 plus 1, 5 minus 4 again, right? Okay, well, if we do this, we say, great, we know that we're going to get a positive value here. We know that we're going to get a positive value here. And we know that we're going to get another positive value, right? Same factor, top and bottom. So positives everywhere means we're just definitely going to get a positive number, which means that this interval is also going to work. So we go back up here and we say, great, this interval also works. The only hole between my middle interval and my right interval is where x is equal to 4, right? Because that's where we can't include that number. That's where our fraction is undefined. So we know that at 4, we have to exclude that number, but otherwise it should work. From -1 to positive infinity, it should work everywhere except at 4. So we just have to go ahead and write our final solution, and our final solution is from -1, we don't include -1. Remember, it's not greater than or equal to 0. It was just greater than 0. So -1 all the way to 4. We don't include 4. And then from 4 to infinity. And that's your final solution. Okay? So once again, what are we doing? Well, we factor, right? We started with a quadratic up top. We factor. We do not cancel out, because canceling out means we're essentially getting rid of the 4. And now I want you to just keep in mind what would have happened if we did cancel. If we canceled out that 4, then we would have ended up with this number line instead, which I'm going to draw in red because I want to really just illustrate that it's incorrect. We would have ended up with -1, and we would have just had 2 intervals, right? And we tested -2, so we know we would have had a negative here, and we would have had, so the left side wouldn't work, but we would have tested probably like 2 or 3 or something, right? Or 0, in fact. We tested 0 before, and 0 ended up working, right? So we would have had this, and nothing would have told us to test at -4, right? Or I'm sorry, at x is equal to 4. So we would have just said our final solution would have been from -1 to infinity, but notice that is not the same. That is not the same as -1 to 4, excluding 4, and 4 to infinity, because at 4 this breaks. Okay, so this is why we can't cross out x minus 4. Okay, but again, same process. We factored, we set our numerator and denominator equal to 0, which means each factor equal to 0. I had x minus 4 twice, so I only wrote it once here. Then we plotted them onto our number line. We did our test points, and we saw that 2 intervals worked, and our final solution, once again, from -1 to 4, 4 to infinity. Okay, so with all that being said, I know that was like a mouthful, and that was a lot of work. Just go ahead and give your last classwork a shot, and hopefully this, works out. Okay, so hopefully this isn't too bad. Okay. Your last classwork is x squared plus 2x minus 15 all over x minus 1 and greater than or equal to 3. Okay, so doing this one, what we have to do is the same process that we did when we had a 1 on the other side, right? So the very first thing that we do is we're going to move over that 3. So we have x squared plus 2x minus 15 over x minus 1 minus 3 is greater than or equal to 0. Okay, well, we have to get 3 to be a fraction. So we get x squared plus 2x minus 15 over x minus 1 minus 3x minus 1 over x minus 1, right? We have common denominators now, so now we can go ahead and subtract everything. So we get x squared, and I made a very bad mistake. You should always carry down that inequality sign. So sorry about that, but just always carry it down with you. So x squared plus 2x minus 15 minus, and now 3 times x is 3x. And remember that negative sign is going to carry over, right? So negative 3 times a negative 1 is going to be a positive 3. And now this is all over x minus 1. Okay, so now we just have to do some simplifications here. Nothing's happening to our x squared, so that stays the same. So we have positive 2x minus 3x. We get a negative x. We get negative 15 plus 3, and that's going to give us a negative 12, right? Now all over x minus 1 greater than or equal to 0. Okay, so we have to factor our top now. So factoring x squared minus x minus 12, we look at factors of negative 12 such that they give us a negative number, but add to give us a negative 1, right? So that should be x minus 4 and x plus 3 over x minus 1 is greater than or equal to 0. So now when we set all these equal to 0, we're going to see that we have 3 points this time as opposed to having 2 like we had in all the other examples. So we have x minus 4 is equal to 0, x plus 3 is equal to 0, and x minus 1 is equal to 0. And we get x is equal to 4, x is equal to negative 3, x is equal to 1. So we go ahead and plot these on the number line, all 3 of them. So we're going to have negative 3, we're going to have 1, we're going to have 4. Right? Now we just have to go ahead and decide what's going to be filled in and what's not going to be filled in. Well, the things on the numerator should be filled in, right? 4 and negative 3, those should work. Because if we plug in 4, we're going to get a 0 up top. We're not going to get a 0 on the bottom. So we get a 0 over some number, and 0 is greater than or equal to 0. Same thing with negative 3, right? So we can go ahead and fill these in with closed circles. But what about at 1? Well, at 1, we get 1 minus 4, which is negative 3, so we get a negative number. And then we get 1 plus 3, which is a positive number, so we still get a negative number up top. But we get 1 minus 1 in the denominator, which is 0 in the denominator, which means, once again, our fraction is undefined, right? You can't divide by 0. So we have to put an open circle by default because you can't divide by 0. We have to exclude 1. Okay? So now we have 4 intervals that we have to test. We have here, 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 and here, right? 4 different intervals that we have to test. So we choose test points. I'm going to pick negative 4. I'm going to go ahead and pick 0 here, 2, and 5. Feel free to pick different numbers than me. I'm just picking the ones that are intuitive, pretty close to, making this as easy as I can for myself. So we just go right along and we test. So testing. And we're going to do negative 4, right? And our original was x minus 4, x plus 3 over x minus 1, right? X minus 4, x plus 3. Yep. Okay, great. So we plug in for negative 4. We get negative 4 minus 4, negative 4 plus 3 over negative 4 minus 1. Well, negative 4 minus 4 is going to give us a negative number. We get negative 4 plus 3, that's another negative number. And negative 4 minus 1, that's a third negative number. So because they cancel in pairs, we know that we're just going to get a negative number back. And what were we looking for? We were looking for all the numbers bigger than or equal to 0, right? So we were looking for positive numbers. So is a negative number a positive number? The answer, very obviously, is no. So this does not work out. And we can say, great, we put a negative number here. We do not shade in that region. It does not work. Okay? Now we test 0. So testing 0, we would get 0 minus 4, 0 plus 3, 0 minus 1. Well, we get a negative, a positive, and a negative. Negatives cancel in pairs. And as a result, we're just left with our positive number. And positive is, in fact, greater than or equal to 0. That one works. So we come back up here. We shade in this area because that will work. We go ahead and we test 2. So testing 2, we get 2 minus 4, 2 plus 3, 2 minus 1. Okay, we get a negative, we get a positive, and we get a positive, right? 2 minus 1 is positive, okay? So, well, positive times a negative is negative. Over positive, we still get a negative number. And negative is not equal to or greater than 0, so that one doesn't work. And last test is 5, right? So testing 5, we get 5 minus 4 times 5 plus 3 over 5 minus 1. And 5 minus 4 is positive. 5 plus 3 is definitely positive. 5 minus 1 is still positive. All positive, so we know it's definitely positive. And positive is, in fact, greater than 0. So this one works too. So now we just have 4 going all the way to infinity. And that one definitely works as well, right? And I just want to shade that in a little more. Sorry, my OCD is killing me. Okay, so we say that we have 2 intervals that work and 2 intervals that don't, right? So we just need to put them together. So our final solution is from -3, and remember, bracket because we're including -3, and it goes all the way up until we hit 1, right? Do we include 1? No, right? Open circle. And we have the other interval from 4. Once again, we're including 4, and it goes all the way to positive infinity. So we put the parentheses for the infinity, and we just have to put the u because we're joining them together. And this is our final solution. Okay, so one more time, just to recap, what did we do? Well, we wanted one of the sides to be 0, so we moved the 3 over. We put a common denominator for our 3, so that way we can combine it and get it into one fraction. Okay, so doing so, great. We have x squared minus x minus 12 after our simplification, and that was what was up top. We know then that we could factor it. So when we factored it, we had 2 factors up top, and we had 1 factor in the bottom, that x minus 1, our denominator, which we couldn't do anything with, and we set them all equal to 0. We figured out which ones we're going to shade in on our number line, which were -3 and 4. We figured out also that we couldn't shade in x is equal to 1 because at 1, our fraction is undefined, right? We would get a 1 minus 1 in our denominator. Dividing by 0 is not okay. So we leave 1 as an open circle, and then all we have to do is just shade in our regions that worked, right? So we picked test points, we tested all 4 intervals, and we saw that 2 of the 4 intervals worked, 2 of them didn't. So the ones that worked were from -3 to 1, including -3, and from 4 to infinity, including 4. So this is our final solution. Okay, guys, hopefully it wasn't too bad for you. That's it for inequalities. We'll be moving on to our next topic on going into Wednesday, which I believe is absolute equations with absolute values, if I'm correct. So yeah, if you guys have any questions, feel free to reach out. Otherwise, please enjoy the rest of your day or night or whenever you're watching this, and I will talk to you guys soon. Have a good one.